Everyone, welcome to problem number 19. Remove the nth node from the end of the list. Okay, so given the head of the linked list, remove the nth node from the end of the list and return the head. So we just have to pluck out the nodes from the back, okay, not from the front. So if we have, say, head is pointing to the root node that with the linked list as 1, 2, 3, 4, 5 and equals 2, that means second from the back. So we will be plucking out 4. And say head is just 1 and we have to pluck out the first from the back, then we'll just return the empty. Okay, similarly 1 2 n is 1, then we would be plucking out 2, so the first node from the back. So what are the constraints? And the number of nodes in the list sz is like it has the minimum of 1, maximum of 30, and node value can be from 0 to 100, and the n could go from 1 to SCSL as well. So n is the number that we have to pluck out from the back. Okay, so how would we go about doing it? Couple of things here. So if we have like which node to pluck, so node to pluck here in this case, so the length of the linked list is 5, right? And the node second node from the back, so we have to pluck out node number 3, which is basically 0 1 2 and 3, right? So here the index is 3. Similarly, if the head is 1, so the length of the linked list is 1, and then we have to pluck out the first node from the back, so we have to pluck out the 0th index, right? Similarly, if we have 1 2, so the length is 2, and the node to be plucked out from the back is 1, so we have to pluck out the first index node. So here 0 and 1, so that's how we are plucking it out. Okay, so that's the idea. Let me try writing a code in a brute force way and see if we can make a better approach out of that. Okay, so let's go ahead about writing it. So how would you find the length of the linked list? So length would be 0. Say we have a current pointer pointing to head, so while current not equals none, length plus equals 1, current goes to currents next. Fine, and now we have the length. Okay, so node to pluck would be the length minus n, right? That's where we have to pluck the index out of. Okay, now what we can do, so we have we can take 2 pointers pointing to head right now, so previous points to head, and fast also points to head, and then we will actually iterate till the node itself. So what you can do, so while node to pluck, so then index, while it is there, what we can do is previous goes to fast, like the current, we can just take current. So previous goes to current and current goes to currents next, right? And then we will just decrement this. So with me, so now we have say n equals 1 2, so 5 minus 3 3, right? So we'll go 3 2 1 and 0. So till it is 0, this is where the current would be and this is where the previous would be, right? So at the end, what we have to just do is previous dot next equals, this is how you delete node in the linked list, right? So previous next, which is now 4, so it would go to the next of next, so 5. Okay, this is only possible if current is if there is a current, so current as in like the current pointer, if the current pointer itself is 0, then we just have to uh, ground the previous nodes, right? So this is very important here. Okay, so this is number one, and then we are missing out the important condition as well. So say there is no node at all, so something like this 1, and the length of the linked list is 1, and we have to pluck out the first node. Then we can just do if not node to pluck, then what we can do is just return head dot next. So we don't have to go through all this slow and fast, so previous and current drama, because we have to delete the first node from the total linked list. So what you can just do is just pluck out the first one and return the head itself. So that's pretty much it, and at the end we would just return the head. Okay, let's see if it works. Okay, and we'll submit it, and it goes through. Okay, let's see if we can come up with a better approach. There's something called as tortoise and hare approach. It's pretty much the same as what we did here, taking up the 2 pointers, but instead of calculating the length, so as of now the code is taking 2 passes, right? So the first one to identify the length of the linked list, and second one is to actually traverse it. Instead of this, what we can do, so this is where we would start making the changes. Previous and current would stay the same. Note this one would actually change as well. Well, let me actually just comment this out. Start from the very beginning, right? So let's take 2 pointers. This is how you implement tortoise and hare. It's just a fancy name of taking 2 pointer approach as well. So for I in range n plus 1, so I goes till n plus 1, current goes to currents next. Basically the same thing of traversing it all throughout. And if there is no current, or if current is none, then what we can do, then we will just return the head dot next, right? So if the current actually empties, then we can just return the head dot next. So while current is not none, this is where it gets interesting. So what we can do, so now the previous is pointing to head, still we haven't moved previous. The current is pointing to the current, and then while the current is, so now it would act like a window. So while current is not none, previous goes to previous next, and current goes to currents dot next, right? So basically you will start moving. So this is exactly what we are doing if you follow up the logic here. So node to pluck, we are already at the node to pluck, and sorry, we are already at the nth length. So even to actually go till the end, this is what you'll basically do, right? So that's pretty much it. And you would do slow dot next equals slow dot next, and then we would just return the head. Whoops, did I just say? My bad. Okay, let's see if it works. Okay, my bad. If current okay, I might have missed something. Let's see. So here what you can do, while current dot next is not equals none. Okay, so that's basically to it. Submit it again, much faster. Perfect. Thank you so very much for tuning in. I'll see you guys in the next video. Thanks.